Okay, so this is part 2 of graphing rational functions. In this video, we are going to start by finding horizontal and vertical asymptotes. So we've kind of already talked about vertical asymptotes whenever we found points of discontinuity. So to find vertical asymptotes, factor the denominator if possible, set those factors equal to 0, and then your vertical asymptotes are the x values that cause the denominator to equal 0 that don't cancel. So looking at number 1 here, our denominator is already factored, so we just need to set the denominator equal to 0. So we have x minus 2 equals 0, and then x minus 3 equals 0. In this case, x is going to equal 2, and x is going to equal 3. Now, since it's already factored, does anything cancel? Well, no, it doesn't. So we have two vertical asymptotes, and we abbreviate it VA, at x equals 2 and x equals 3. So graphically, what this looks like is at x equals 2, I have an invisible dotted line, and at x equals 3, I have another invisible dotted line. That means that my domain is split up at 2 and 3. So we go from negative infinity to 2, between 2 and 3, and then, not 2, 3 to infinity. So let's look at a couple more examples. What are the vertical asymptotes for the functions below? State the domain. So in number 2 here, our denominator is not factored, so we have to factor it. So I need two numbers that will multiply to negative 3, but add to 2. My numbers are going to be 3 and negative 1. So this will be x minus 2 over x plus 3 times x minus 1. Now, does anything cancel? Well, no. So we set our factors that don't cancel equal to 0, and then solve for x. So x is going to equal negative 3, and x is going to equal positive 1. That is where my vertical asymptotes exist. Because these don't cancel, these are my vertical asymptotes. So graphically, I have an invisible line at negative 3, and then again at 1. So my domain, again, we want to move left to right, and it's broken up at the negative 3 and the 1. So we go from negative infinity to negative 3, negative 3 to 1, and then 1 to infinity. Let's look at number 2. Number 3. So we have to factor that denominator. So two numbers that will multiply to negative 6, but add to a negative 1. My numbers are going to be negative 3 and a positive 2. So this will be x plus 2 over x minus 3 times x plus 2. Now, I have the x plus 2's, they cancel, okay? So I'm going to come back to that in just a second. So that means the factor that doesn't cancel in the denominator, that's what I set equal to 0. So my vertical asymptote is at x equals 3. But it does affect my domain. The x plus 2, that is a removable discontinuity, which means that it's a hole. So on my graph, yes, I have a vertical asymptote at 3, but I also have something going on when x is equal to negative 2. This is a hole. So somewhere over here, I don't know where along this vertical line, but there exists a hole. So again, your domain, it's broken up at these points of discontinuity. So moving from left to right, my domain would be negative infinity to negative 2, negative 2 to 3, and then 3 to infinity. And that's how you find those vertical asymptotes. It's the factors in the denominator that don't cancel. Now let's look at horizontal asymptotes. These are a whole lot easier to find. You just have to remember an acronym. Bobo Botan eats dark chocolate. That's the acronym. So you are looking at your largest exponents. So Bobo, this is what it stands for. You have big on bottom, y equals 0. So if your largest exponent is in the denominator, your horizontal asymptote is at y equals 0. That's Bobo. Botan is big on top, none. So if your largest exponent is in the numerator, there are no vertical or horizontal asymptotes. Eats dark chocolate. This is exponents are the same. Divide coefficients. So this means that if you have the same exponent in both the numerator and denominator, you take the coefficients of those exponents and you divide them. So let's look at some examples. Find the horizontal asymptote. So we have y equals 2x over x minus 3. So what is my largest exponent in the numerator? So it's going to be a 1. Largest exponent in the denominator is also a 1. So this is an eats dark chocolate. Okay, exponents are the same. We divide our coefficients. So the coefficient in front of that x there is a 1. So we have 2 over 1. Well, that's just 2. So my horizontal asymptote is at y equals 2. Graphically, I have that invisible dotted line, now a horizontal one, at y equals 2. Let's look at a couple more. We have x minus 2 over x squared minus 2x minus 3. So largest exponent in the numerator is a 1. Largest exponent in the denominator is a 2. So is it Bobo, Botan, or eats dark chocolate? Well, we have big on bottom. So this is Bobo. So big on bottom, your horizontal asymptote is y equals 0. That's what that last O stands for, is 0. Okay, and so graphically, at y equals 0, we would have a dotted line, and that's where our horizontal asymptote would be. Number 3, we have x squared over 2x minus 5. So largest exponent in the numerator is a 2. Largest exponent in the denominator is a 1. So overall, the biggest exponent is on top. This is Botan. Okay, big on top, none. So horizontal asymptotes, there are none. So again, graphically, there's just not going to be anything. Okay, and that's how you find horizontal asymptotes. Bobo Botan eats dark chocolate.